Implementation of BYD's Super E platform by Q2 2024, a detailed report. Event summary. On March 17, 2025, BYD announced its ambitious plan for the implementation of the Super E platform, which is set to revolutionize the electric vehicle EV landscape by Q2 2024. This initiative is backed by a significant investment of $150 million aimed at creating an extensive charging infrastructure comprising over 4,000 charging stations capable of delivering 1 megawatt MW of power. Key features of the Super E platform. 1. Ultra-fast charging technology. MegaWatt Flash Charging. This system can deliver up to 1,000 kilowatts 1 megawatt of charging power, allowing vehicles to gain a range of 400 kilometers in just 5 minutes of charging. This groundbreaking technology is made possible by BYD's innovative flash charge batteries, which feature a 10C charging multiplier, the highest in the industry. 2. High voltage architecture. The platform boasts the world's first mass-produced 1.000V all-domain high-voltage architecture. This advancement enhances energy efficiency by reducing energy loss by 12% while simultaneously improving vehicle performance. 3. Advanced motor technology. BYD's Super E platform includes a high-revving motor capable of reaching 30,511 RPM, making it the fastest mass-produced motor globally. This motor can deliver peak power of 580 kilowatts and demonstrates superior power density compared to traditional engines. 4. Silicon carbide power chips. The introduction of next-generation silicon carbide SiC chips rated for up to 1500 volts enhances the reliability and performance of the megawatt charging systems. Models and market launch. BYD plans to launch its first vehicles built on the Super E platform, including the Tang L sedan and the Tang L SUV. Pre-sales for these models commenced on the announcement date, with deliveries expected to begin in April 2025. Pricing for the Tang L ranges from 270,000 renminbi to 350,000, approximately $37,330 to $49,000. While the Tang L is priced between 280,000 renminbi and 360,000. Charging infrastructure development. The infrastructure rollout includes the construction of over 4,000 megawatt flash charging stations. These stations will feature dual-gun charging capabilities and smart voltage boosting technology, enabling existing supercharger facilities to upgrade to meet the new standards. This initiative is projected to significantly reduce charging anxiety among EV users by matching traditional refueling times, thereby promoting greater adoption of electric vehicles. Industry impact and collaboration. BYD's advancements mark a transformative shift in the EV market. The Super E platform and its associated charging infrastructure are expected to reshape energy networks and vehicle design, facilitating a seamless coexistence of electric and fossil fuel vehicles. BYD is also encouraging collaboration with industry partners to further develop high-power charging components, aiming for a rapid transition to sustainable transportation. Timeline of events. March 17, 2025. BYD unveils the Super E platform and MegaWatt Flash Charging technology, initiating pre-sales for the Tang L and Tang L models. Q2 2024, targeted completion date for the implementation of the Super E platform with ongoing construction of the charging infrastructure. April 2025, expected launch and official delivery of the Tang L and Tang L models. Conclusion. The development of BYD's Super E platform signifies a monumental advancement in the electric vehicle sector, characterized by its ultra-fast charging capabilities, cutting-edge battery technology, and an extensive infrastructure plan. This initiative not only enhances the electric vehicle ownership experience but also sets new performance and efficiency benchmarks in the evolving landscape of sustainable transportation. BYD's commitment to revolutionizing the EV market positions it as a leader in the transition towards a more sustainable future. Sources. 1. Electric. BYD confirms 1000V Super E platform fast charging. 2. CNEV Post, BYD unveils new EV platform with 1,000 kW supercharging support. 3. Fiverr New Energy Technology, BYD unveils MegaWatt Flash Charging and Super E platform redefining EV charging standards. This report encapsulates the significant milestones and technological advancements introduced by BYD as it gears up for a transformative impact on the electric vehicle market by leveraging the Super E platform and its extensive charging infrastructure. The implementation of BYD's Super E platform represents a significant shift in the electric vehicle EV landscape, particularly concerning charging infrastructure and technology. Here are several counterintuitive points gathered from the content regarding this initiative. 1. Charging time versus driving range. While traditional EV charging often leads to extended wait times, the Super E platform's MegaWatt Flash Charging system allows for 400 kilometers of range to be added in just 5 minutes. This drastically reduces the conventional notion that EVs take longer to charge compared to filling up a gas tank. The expectation of charging times matching those of conventional refueling is a major psychological shift for consumers. 2. High voltage architecture. The introduction of a 1000 V architecture is not merely an incremental improvement but a radical rethinking of how energy is transferred in EVs. This high voltage system enables a significant reduction in energy loss 12%, which runs counter to the belief that higher voltages are inherently less efficient due to losses in transmission. BYD's architecture challenges the conventional wisdom by demonstrating that higher voltage can actually lead to greater efficiency in energy use. 3. Motor speed and power density. BYD's new high-revving motor, capable of reaching up to 30,511 RPM, is not just a technical marvel, it defies traditional expectations regarding the limitations of electric motors. Typically, electric motors are not associated with such high revolutions per minute RPM due to concerns about wear and thermal management. This motor's peak power of 580 kilowatts surpasses that of many traditional internal combustion engines, including V12 engines, suggesting that electric motors can compete with or exceed the performance of their fossil fuel counterparts in ways previously thought impossible. 4. Silicon carbide SiC utilization. The use of silicon carbide SiC chips rated for 1500 volts is counterintuitive considering the trend of relying on traditional silicon technology. By leveraging SiC, which can handle higher voltages and temperatures, BYD effectively enhances the performance and reliability of its charging systems. This move highlights the potential for advanced materials to disrupt established technologies, suggesting that more efficient and higher performing components can be achieved through innovative materials rather than conventional methods. 5. Investment in infrastructure. The substantial investment of $150 million for over 4,000 charging stations may initially seem disproportionate given the current scale of EV adoption. However, this strategy reflects a proactive approach to creating a robust support system that anticipates exponential growth in EV usage. The counterintuitive aspect here is the belief that infrastructure should only expand in response to demand. BYD is instead choosing to create an environment that encourages demand through improved accessibility and convenience. 6. Dual-gun charging. The implementation of dual-gun charging technology, allowing multiple vehicles to charge simultaneously at high speeds, challenges the conventional model where charging stations serve one vehicle at a time. This innovation indicates a shift towards maximizing the utility of charging stations and addressing the issue of wait times, which is a common concern among potential EV users. 7. Collaboration invitation. BYD's open invitation for industry collaboration to develop high-power charging components suggests a strategic move that contrasts with the competitive tendencies of many tech companies. Instead of keeping innovations proprietary, BYD is fostering an ecosystem that could lead to rapid advancements in EV technology, indicating a belief that cooperation can accelerate the transition to sustainable transport more effectively than isolationist practices. 8. Market positioning. The pricing strategy for the Han L and Tang L models places them in a competitive range, which may seem counterintuitive given the high technological advancements they represent. Instead of positioning these vehicles as luxury items due to their cutting-edge features, BYD is making them accessible, which could lead to broader adoption and normalization of high-performance EVs among average consumers, thereby disrupting the luxury EV market. 9. Perception of charging anxiety. The initiative aims to eliminate charging anxiety by matching traditional refueling times. This approach counters the prevalent perception that EVs are less convenient than gasoline vehicles due to charging time. By bridging this gap, BYD may change consumer attitudes towards EVs, which have often been viewed as impractical for long-distance travel. 10. Energy storage integration. The integration of energy storage facilities into charging stations to support high-power charging even in areas with limited power capacity is a strategic move that contradicts the typical expectation that charging infrastructure must rely solely on existing grid capabilities. This innovative approach could ensure the feasibility of robust charging networks in diverse locations, enhancing overall infrastructure resilience. In summary, BYD's Super E platform and associated MegaWatt Flash Charging system presents several counterintuitive shifts that challenge conventional wisdom in the electric vehicle market. These innovations not only enhance performance and efficiency but also redefine consumer expectations and the infrastructure necessary to support the EV ecosystem. The implementation of BYD's Super E platform by Q2 2024 is a significant milestone in the electric vehicle EV industry, marked by a $150 million investment that aims to establish a robust charging infrastructure comprising over 4,000 stations capable of delivering 1 megawatt MW of power. While the key features and anticipated market impact of this initiative have been widely discussed, certain critical elements may be overlooked by many stakeholders. Here's a closer examination of these components and their significance. 1. MegaWatt Flash Charging Technology. The introduction of the MegaWatt Flash Charging system, capable of delivering up to 1,000 kilowatts, is a transformative leap in charging technology. While many may focus on the impressive numbers, such as the ability to charge a vehicle for 400 kilometers in just 5 minutes, what's often overlooked is the underlying technology that enables this capability. The flash charge batteries developed by BYD employ a 10C charging multiplier, which is revolutionary. This means the batteries can theoretically be charged to full capacity in just 6 minutes. The significance of this rapid charging capability lies in its potential to eliminate charging anxiety, a common barrier to EV adoption. Consumers are more likely to embrace electric vehicles if they can charge them in a time frame comparable to refueling a traditional gasoline vehicle. This technology could redefine user expectations and accelerate the shift from fossil fuel vehicles to electric ones. 2. High voltage architecture. BYD's Super E platform boasts the world's first mass-produced 1.000V all-domain high-voltage architecture. This innovation optimizes energy efficiency by reducing energy loss by 12%, which is crucial for both vehicle performance and battery longevity. The significance here extends beyond just numbers. It lays the groundwork for future advancements in EV technology. As the industry moves toward higher voltage systems, BYD's early adoption places it at the forefront of this shift. This could lead to a new standard in EV design where vehicles are not just more efficient but also more powerful, challenging the traditional paradigms of automotive engineering. 3. Advanced motor technology. The Super E platform features a motor that can reach 30,511 RPM, which is the fastest mass-produced motor globally. This motor achieves a peak power of 580 kilowatts, surpassing the performance of many high-end combustion engines. The overlooked aspect here is the implications of such advancements for performance and design. A motor with this power density allows for lighter vehicle designs and can enable new vehicle configurations in use cases, e.g. sports cars, heavy-duty vehicles that were previously impractical with conventional motors. This could open new markets for BYD and redefine consumer expectations for electric vehicle performance. 4. Silicon carbide power chips. BYD's development of next-generation silicon carbide SiC chips rated for up to 1,500 volts is another vital detail that could be easily overlooked. These chips enhance the reliability and performance of the MegaWatt charging systems. The significance of these chips lies in their ability to handle higher voltages and currents, which are crucial for the next generation of charging infrastructure. As the demand for charging power increases, the need for efficient and reliable semiconductor technology becomes paramount. BYD's early investment in SiC technology may provide a competitive edge as the industry moves toward higher capacity charging solutions. 5. Charging infrastructure and user experience. While the establishment of 4,000 MegaWatt Flash Charging stations is a cornerstone of this initiative, the integration of features such as dual-gun charging and smart voltage boosting technology is often overshadowed. These features are significant because they not only allow existing supercharger facilities to upgrade but also ensure that the new infrastructure is adaptable to various power conditions. This flexibility is essential in regions with inconsistent power supply, allowing for a more robust and user-friendly charging experience. By addressing these logistical and technical challenges, BYD can facilitate broader EV adoption, particularly in markets that may be hesitant due to infrastructure limitations. 6. Industry collaboration and future trends. BYD's invitation for collaboration with industry partners represents a strategic move that is often underappreciated. The company recognizes that the future of sustainable transport will require collective effort across the industry. This collaborative approach is significant for several reasons. Firstly, it signals BYD's commitment to establishing a new standard for EV charging, which may influence regulatory frameworks and industry norms. Secondly, by fostering partnerships, BYD can accelerate the development and deployment of high-power charging components, ensuring that the infrastructure keeps pace with vehicle advancements. This could potentially lead to an oil-electric parity era, where the convenience of charging matches that of traditional fueling. Conclusion. The nuances of BYD's Super E platform and its MegaWatt Flash Charging initiative represent not just technological advancements but a strategic vision for the future of electric mobility. The potential to redefine user experiences, enhance vehicle performance, and reshape industry standards is tremendous. While the headline figures and features are impressive, the overlooked aspects, including the implications of high-voltage architecture, advanced motor technology, and collaborative strategies, are what will ultimately determine the success of this initiative. BYD's proactive approach positions it as a leader in the rapidly evolving EV landscape, potentially setting new benchmarks for performance, efficiency, and user adoption in the electric vehicle market. 1. Ultra-fast charging technology. BYD's introduction of the MegaWatt Flash Charging system is a significant advancement in electric vehicle EV charging capabilities. With a charging power of up to 1,000 kW 1 MW, this system allows vehicles to gain an impressive 400 km of range in just 5 minutes of charging. This breakthrough effectively reduces charging times to approximately 1 second per 2 km of range. The technology is made possible by BYD's flash charge batteries, which utilize a 10C charging multiplier, the highest in the industry. This ultra-fast charging capability addresses one of the most significant barriers to EV adoption: charging time anxiety. 2. High-voltage architecture. The Super E platform features the world's first mass-produced 1000V all-domain high-voltage architecture, which enhances energy efficiency by reducing energy loss by 12%. This innovation not only improves overall vehicle performance but also facilitates the integration of various vehicle systems, including battery systems, motors, and power supplies, all within a unified high-voltage framework. The high-voltage architecture is crucial for supporting the MegaWatt charging technology, making it a cornerstone of BYD's strategy to lead in the EV market. 3. Advanced motor technology. Another key feature of the Super E platform is its advanced motor technology, which includes a high-revving motor capable of reaching 30,511 RPM. This motor not only has a peak power output of 580 kilowatts, making it the fastest mass-produced motor globally, but also boasts an impressive power density that surpasses traditional engines. The capabilities of this motor are essential for enhancing the performance of BYD's vehicles, allowing them to compete effectively with internal combustion engine vehicles and appeal to performance-oriented consumers. 4. Comprehensive charging infrastructure development. BYD's plan to establish over 4,000 MegaWatt Flash Charging stations across various locations is a pivotal aspect of their strategy to promote electric vehicle adoption. This infrastructure rollout will feature advanced charging technologies such as dual-gun charging and smart voltage boosting, which will upgrade existing supercharger facilities to meet new standards. By alleviating charging anxiety and providing a robust support network for EV users, BYD aims to facilitate a smoother transition to electric mobility, ultimately contributing to a broader shift towards sustainable transport solutions. These 4 points highlight the transformative potential of BYD's Super E platform and its associated infrastructure, positioning the company as a leader in the evolving electric vehicle landscape. Together they underscore a comprehensive approach that addresses key challenges in the EV market, paving the way for increased adoption and integration of electric vehicles into everyday life. 1. The development of the electric grid. Late 19th, early 20th century. The establishment of the electric grid revolutionized energy distribution. Much like BYD's Super E platform aims to transform electric vehicle charging infrastructure. The expansion of electric networks in urban areas. Led by companies like Thomas Edison's Edison Electric Light Company and George Westinghouse's Westinghouse Electric Corporation, involved significant investments in infrastructure to ensure widespread access to electricity. They rolled out thousands of miles of transmission lines and substations, facilitating the adoption of electric lighting and appliances, similar to BYD's plans for over 4,000 charging stations. 2. The Ford Model T in mass production. Early 20th century. The introduction of the Ford Model T in 1908 marked a pivotal moment in automotive history, akin to the potential impact of BYD's Super E platform. Ford's innovative assembly line reduced production costs and made automobiles accessible to the masses, leading to a proliferation of car ownership. Similarly, BYD's platform aims to make electric vehicles more efficient and user-friendly with ultra-fast charging capabilities that could drive widespread electric vehicle adoption, just as the Model T did for gasoline vehicles. 3. The launch of the Internet. 1990s. The rollout of the Internet during the 1990s represented a transformative phase in global communication and commerce, paralleling BYD's ambitious plans for EV infrastructure. Just as the Internet required significant investments in infrastructure, including fiber optic networks and data centers, BYD's $150 million investment in charging stations aims to build a robust network to support the growing electric vehicle market. This infrastructure is essential for facilitating connections and interactions in a new digital economy, much like how BYD's Super E platform seeks to enable a new era of electric mobility. Future outlook for BYD's Super E platform and MegaWatt Flash Charging infrastructure. As BYD prepares to launch its Super E platform and MegaWatt Flash Charging technology by Q2 2024, the implications for the electric vehicle EV market, charging infrastructure, and broader transportation landscape are profound. With a projected investment of $150 million to establish over 4,000 ultra-fast charging stations, BYD is poised to redefine both the user experience of EV ownership and the operational framework of EV infrastructure. The following predictions outline potential developments in the coming years. 1. Acceleration of EV adoption. The Super E platform's ultra-fast charging capabilities, allowing 400 kilometers of range from a 5-minute charge, is expected to significantly reduce charging anxiety among consumers. As charging times approach, the convenience of traditional refueling, the barriers to EV adoption will diminish. By 2026, a marked increase in EV sales is anticipated, particularly in markets where charging infrastructure is robustly developed. The ease of use and accessibility provided by BYD's charging network may inspire other automakers to invest in similar technologies, leading to a more competitive EV landscape. 2. Transformation of charging infrastructure. The establishment of over 4,000 MegaWatt Flash Charging stations will transform the EV charging ecosystem. These stations will not only provide rapid charging but will also incorporate advanced features such as dual-gun charging and smart voltage boosting. As these stations become operational, they will set new standards for charging efficiency and reliability, prompting upgrades in existing infrastructure across the industry. By 2025, it is predicted that many traditional gas stations will begin to convert to EV charging hubs, reflecting a shift in consumer behavior toward electric mobility. 3. Impact on energy demand and grid management. The implementation of BYD's high-voltage architecture and the MegaWatt Flash Charging technology presents challenges and opportunities for energy management systems. The increased demand for high-capacity charging will necessitate improvements in grid infrastructure, including energy storage solutions to manage peak loads effectively. Utilities may collaborate with BYD and other EV manufacturers to develop smart grid technologies that can adapt to the fluctuating demand created by rapid charging stations, ensuring that energy supply aligns with consumer needs. 4. Enhanced vehicle performance and innovation. BYD's focus on advanced motor technology and silicon carbide SiC power chips will likely inspire further innovations in vehicle design and performance. The introduction of high-revving motors and high-power batteries will set benchmarks for performance, encouraging other manufacturers to enhance their offerings. By 2027, it is expected that the market will see a proliferation of high-performance EVs that not only match but exceed the capabilities of traditional internal combustion engines, thereby attracting a broader consumer base. 5. Collaborative developments in the EV ecosystem. BYD's open collaboration model will likely foster partnerships with other industry players, including charging infrastructure providers, battery manufacturers, and software developers. This collaborative approach will accelerate the development of interoperable charging solutions and standards, making it easier for consumers to transition between different charging networks. By 2028, a unified standard for high-power charging may emerge, further simplifying the EV ownership experience and encouraging cross-industry partnerships. 6. Global market dynamics and competitive landscape. As BYD strengthens its position in the global EV market, competition will intensify. Traditional automakers and new entrants will respond to BYD's innovations with their own technological advancements and infrastructure investments. By 2029, we may witness a significant shift in market share among leading EV manufacturers, with companies that adapt quickly to changing consumer expectations and infrastructure advancements gaining an edge. 7. Sustainability and environmental impact. The transition to electric vehicles, coupled with BYD's commitment to sustainability, will contribute to a reduction in greenhouse gas emissions. As more consumers opt for EVs, the cumulative effect on air quality in urban environments is expected to be positive. By 2030, cities with robust EV infrastructure could see a marked improvement in urban air quality and a shift toward cleaner transportation solutions, fostering a healthier environment for residents. Conclusion. The implementation of BYD's Super E-platform and MegaWatt Flash Charging infrastructure signals a pivotal moment in the evolution of electric vehicles and charging technology. The predictions outlined above suggest a future characterized by accelerated EV adoption, transformed charging infrastructure, and enhanced vehicle performance. As the industry moves toward a more sustainable and efficient transportation model, BYD's innovations are likely to play a critical role in shaping the future of mobility. The next few years will be crucial in determining how these developments unfold and how they influence consumer behavior, market dynamics, and environmental outcomes.